Ladies and gentlemen, this is Ms. Humbert here. Today we're going to be doing Unit 1, Notes 6. So we're going to be talking about point-slope form, which is another form of lines that we're going to be using. And each form of line kind of has its own purpose and how it'll help us moving through. So point-slope form looks like this. It's y minus y1 is equal to m times x minus x1, where x1, y1 is a point on the line. Okay, so sometimes that can be really confusing for students. So I actually say, okay, let's look at this as a puzzle. So I like to set up point slope form as a puzzle. So this right here, so this we're going to put the opposite of our y coordinate. So when we're given a point, we're going to put the opposite of what that y point is. Here, we're going to put in the slope. And here, we're going to put in the opposite of our x-coordinate. So sometimes students find that puzzle method a little bit easier than just kind of memorizing that formula as is. So when do we use it? Well, we use it to write linear equations when we're given a point and a slope, or if we're given 2 points. So we're going to go ahead and we're going to practice through each of those. So let's go ahead and let's take a look at that. So we're just going to write these in point slope form. So I'm going to go ahead and set up my puzzle. Okay, so in here is going to go the opposite of the y-coordinate. Well, since the y-coordinate is a positive 2, I'm actually just going to do minus 2. And then I'm going to put my slope of negative 6 right here. And then, since my x-coordinate is a positive 9, I'm going to do the opposite and I'm going to write minus 9. And guess what? That right there is point slope form. That's all you needed. Okay, so then let's go ahead and let's write out this in point slope form as well. Okay, so then here, opposite of my y-coordinate, so since it is a negative 3, or I'm going to write a plus 3. So I want you guys to notice that I didn't put y3, that I actually put y plus 3. And then my slope is going to be 2. And then my x-coordinate is negative 2, which I'm going to write as x plus 2. Okay, and that's it. That's point slope form. Again, let's do the same now for number 3. And I like to change my colors and make it pretty. So we have this, like so. Opposite of my x, y coordinate. So my y coordinate is negative 5. So the opposite of that is going to be plus 5. And you actually need to write the plus sign in. Then here I'm going to put my slope, which is a negative 2/3. That's a 3, whether you believe it or not. And in here, finally, I'm going to put the opposite of my x-coordinate. So that's going to be x minus 2, since my x is positive. Let's take a look at number 4. So for number 4, same thing. Set up my puzzle. Okay, well, opposite of my y-coordinate, since it's a positive 4, I'm going to have minus 4. And then here, I'm going to have 1/2. And then here, since I have a negative 3, I'm going to write x plus 3. Okay, so I'm not going to do x3. You need to actually have that plus sign in there. Okay. So let's go ahead and let's take a look at number 5. So now it asks us to write the equation in point slope form. Well, we're only given 2 points. So for point slope form, you need 2 things. You need a point and you need a slope. Well, guess what? We don't have a slope. Thankfully, on practice 4, we learned how to calculate out the slope. So that's what we're going to do for this. We're going to calculate out the slope. So remember that equation to get the slope is y2 minus y1 over x2 minus x1. Feel free to jot that down on your new notes if you want to. So I'm going to do y2, which is 4, minus y1, so I'm going to subtract off a negative 12, divided by x2 minus x1. Well, this is going to become plus a positive. 4 plus 12 is 16. And then 8 divided by, or 8 minus 4 is 4. So then I have 16 divided by 4. So then my slope is going to be 4. So now we can plug that into point slope form. And actually we have 2 points. So we can choose which one we want to plug in. Both of these points, whether it looks like it or not, will equal the same line. Okay, so it doesn't matter which point you choose as long as you pick one point and stay to it. So let's use for negative 12. Okay, so opposite of my y-coordinate is going to be a positive 12 since it's a negative 12 in there. So I'm going to put plus 12 there. And then my slope is going to be 4, like we talked about. And then my x-coordinate, we want to do the opposite of the x-coordinate, which is going to be minus 4. So that right there is the point slope form. You also could have done y minus 4 is equal to 4 times x minus 8. That would have worked as well. So let's go ahead and let's take a look now at number 6. So we're going to do y2 minus y1 minus a negative becomes plus a positive over x2 minus x1, again, plus a positive. So now I'm going to get 9 over 6. Now 9 and 6 are both divisible by 3. So since they're both divisible by 3, I'm going to divide them both by 3, and I'll get 3 halves. So then I can put that in point slope form. Now remember I said it doesn't matter what point you use, so let's just pick the second one, okay? So opposite of a positive 2, we're going to subtract 2. Then we're going to put in our slope of 3 halves here. And then opposite of 2 again is going to be this. Now if you had written the other version, that is equally as correct, okay? So you can do both. Let's do a couple more practice problems with that. So let's go ahead here and calculate out the slope. So we have y1 or y2 minus y1 over x2 minus x1. So negative 3 minus 1 is going to give me negative 4. 0 minus 2 is going to give me a negative 2. So and I end up getting negative 4 divided by negative 2, which is a positive 2. So my slope is a positive 2. So let's go ahead and let's put it into point slope form. Again, it doesn't matter what point you choose. So my slope is 2, and let's use that first point. So my y-coordinate is 1, so the opposite is going to be minus 1. My x-coordinate is 2, so the opposite is going to be minus 2. And that right there is your slope-intercept, or your point-slope form, not slope-intercept. I'm getting ahead of myself. All right, so let's take a look at this next one. We're going to calculate out the slopes. We're going to have y2 minus y1, subtracting a negative is going to become plus a positive, x2 minus x1. So then I'm going to end up getting 4. 2 minus 0 is 2, and then 4 divided by 2 is 2. So again here, my slope is going to be 2. So let's go ahead and we're going to set that up into point slope form. Okay, so my slope is 2, or I can just draw a random line. My slope is 2, okay? Then let's use this first point here. Opposite of my x-coordinate is going to be a plus 1. And then I'm going to subtract 0, which really doesn't mean anything, but we'll just leave it there so it stays in point slope form. So that's our final answer for number 8. So now for number 9, we're going to do a little bit of extra work. We want to write things in slope-intercept form, and here's why this becomes so important. In order for us to be able to graph things, it has to be in point-slope form. So once we're given a slope and a point, if we need to write something to graph it, it needs to be in slope-intercept form. So let's go ahead and let's practice with that. So first thing I'm going to do is plug this into slope-intercept, or point-slope form, I'm sorry. It's a lot of words in one place. So we're going to do a negative 3 here, opposite of my y-coordinate. Well, since it's a 3, my opposite's going to be a minus 3. And since it's a negative 2, my opposite of my x-coordinate is going to be a plus 2. So now, in order for this to be in slope-intercept form, we're going to have to solve it for y. So I'm going to start by distributing in my 3, my negative 3. So I have y is equal, minus 3 is equal to a negative 3x, and then negative 3 times 2 is going to give me minus 6. So the last thing I need to do to solve for y is I need to get that minus 3 over to the other side. And I do that by adding 3 to both sides. So then this is just y on this side, and then I get a negative 3x minus 3. Okay, so that's your final answer for number 9. Now, let's take a look at number 10. So for number 10, again, we're going to put that into slope-intercept form. So my slope is 2, and here I'm going to do the opposite of the y-coordinate. So since it's a positive 5, it's going to be minus 5. Okay, then here, since it's a negative 4, I'm going to have a plus 4. So now, in order to get that into slope-intercept form, we need to solve it for y. So the first thing I like to do is to distribute. So I'm going to have y minus 5 is equal to 2 times x, which is 2x, and 2 times 4, which is 8. So now the last thing I need to do to get that into slope-intercept form is I need to get that minus 5 over to the other side. Well, since it's being subtracted, in order to get it over to the other side, I just need to add 5 to both sides. So then I get that y is equal to 2x, and then 8 plus 5 is going to give me 13. So that right there is your final answer for number 10. Now, let's take a look at number 11 and number 12. So it's going to be the same kind of thing as what we've been doing. So let's go ahead and let's do that. So we're going to have y, and we're just going to set up our puzzle to do point slope form. Okay, so our slope is 4, so I put that here. Our opposite of our y-coordinate, well, since it's a positive 7, the opposite is going to be a negative 7. And then since it's a positive 6, our answer is going to be a negative 6. So we're going to start by distributing in that 4. So I get that y minus 7 is equal to 4 times x, which is 4x, 4 times negative 6, which is going to give me a negative 24. So now I need to get that minus 7 over to the other side. Again, since it's subtracting, to get it over to the other side, I'm going to add 7. Okay, so then I get y minus 7 is equal to, oops, I already subtracted that 7. Here I was trying to redo the problem all over again. So that's canceled out, so then I get 4x here, and negative 24 plus 7 is negative 17. So that's my final answer for number 11. Now let's take a look at number 12. So I'm going to go ahead and do my point slope form again, like so. And then I'm going to put my slope here. And then opposite of my y-coordinate, since it's a positive 2, it's going to be minus 2 here. And then since it's a negative 4 here, it's going to be plus 4 there. Okay? So now what I want to do is distribute in that negative 1/2. So y minus 2 is going to be equal to, well, negative 1/2 times x is just negative 1/2 x. Now this is what can trip students up. Negative 1/2 times 4, that's the same as 4 divided by negative 2. It means the same thing. So that's going to end up giving me negative 2. So now, since this is being subtracted, I need to go ahead and add 2 to both sides. So then I end up getting y is equal to, we're going to keep the negative 1/2 x the same, and then I have a negative 2 plus 2, which is going to end up being plus 0. So you could write it that way, or the beautiful mathematical way of writing it would just be this without anything at all. I will accept both of those answers though. So let's take one final look at this, and it wants us to write a point, or write something in slope-intercept form given that we have 2 points. So whenever you have 2 points, the best thing to do is just start by finding the slope. So we're going to have y2 minus y1 over x2 minus x1. So 5 minus 1 is 4. 2 minus 0 is 2. 4 divided by 2 is going to give me 2. So let's go ahead and let's plug that into slope-intercept form. Now here's where it's really important when I say it doesn't matter which one. Okay, so let's just pick the second one. So we're going to have 2 here. Opposite of my x-coordinate, since it's a 2, is going to be a negative 2. Opposite of my y-coordinate is a negative 5. So now we need to solve this for y, so we're going to start distributing. So I have y minus 5 is equal to 2 times x, which is 2x. 2 times negative 2 is a negative 4. So now what I need to do, since that is a minus 5, is I need to add 5 to both sides. So then I'm going to get that y is equal to negative, or 2x, sorry, that's going to stay the same. Then I'm going to take the negative 4 and combine it with the 5 to get me plus 1. Now, if you didn't believe me that either point, you can use either point, you could go back and do the same thing with 0, 1, and when you solve it, you will get y is equal to 2x plus 1. Something interesting to keep in mind. So let's go ahead and let's take a look at number 14, our last one here. So first thing we want to do is calculate out the slope. So we're going to do y2 minus y1 over x2 minus x1. When you subtract a negative, remember it's going to become plus a positive. So negative 3 minus 3, remember that's going to get more negative to get me negative 6. 5 plus 1 is going to give me 6. So negative 6 divided by 6 is negative 1. So negative 1 is my slope. So I'm going to go ahead and set that up into point slope form. And I'm going to use the first point this time just because I feel like it. So I'm going to put the slope here, opposite of the y-coordinate there. So since it's a positive 3, the opposite's a negative 3. Okay, then the opposite of a negative 1 is going to be a positive 1, so I'm going to put that in for my x. Notice that I'm always drawing, once I pick the point, I need to make sure I take the x and the y from that same point. So now I'm going to go ahead and distribute in that negative 1. So I get y minus 3 is equal to, well, negative 1 times x is just going to be negative x. Negative 1 times 1 is negative 1. So now to finalize this, I need to add that 3 to both sides. So I'm going to do that, plus 3, plus 3. Then I get that y is equal to negative x plus negative 1 plus 3. That's really the same as 3 minus 1, so that's going to give me 2. So that's my final answer right there. So that concludes your note video for today. Thank you for listening.